We know Earth was like covered in ice and glaciers. Where did that water come from to become glaciers?
Rain.
Where did the rain come from?
The sky.
Since all motion is relative, you cannot declare that you are not in motion and everybody else is.
You can declare you're not in motion, but then as soon as you go on the other side, you're like, oh no, I'm in motion.
Exactly. When the universe was small, there's quantum phenomenon influencing the entire universe.
That is dope as hell.
This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist, co-host Chuck Nice.
Hey, what's up, Neil?
Chuck, baby. All right. You got your sunglasses on your shirt.
Oh, I didn't even realize that.
Was that just a thing?
That was, you know what? That was because when I came in the building, I was wearing sunglasses, and when I walked in, I was like, these security people are going to think you're a douche. Take these sunglasses off right now.
Okay.
Like, do not walk through security with these sunglasses. And they're mirrored sunglasses on top of that.
Yeah,
you know
that's
what
very
I mean?
1985.
Right, I walk in just, what we have here, failure.
To communicate. All right. We got a grab bag cosmic queries today.
Right.
And you've been preloaded.
Yes.
Again, I've never seen any of these questions.
Neither have I.
And they come from our fan base.
Yeah.
Specifically,
Patreon.
the highest echelon of our fan base.
Patreon.
Those who give us money.
Yes.
So what's the category? Oh, no, it's just no category.
No category.
All
this
right.
is what we used to call galactic gumbo.
Gumbo, okay.
Which is so cool.
And once again, we're here in my office at the Hayden Planetarium.
Yes.
The Museum of Natural History.
Absolutely.
Oh, yeah. This is all, everything you see in here, well, you only see this side, but there's like other views here.
It looks like the smartest hoarder in the world lives here. That's honestly what it looks like. Like some kind of genius hoarder just moved in and has a love affair with the cosmos. It's crazy.
Yeah,
it's like
weird.
all kinds of stuff. Mostly a lot of great books though. Like, you know what I mean? All around.
All right.
And then of course, you know, your icons. We see your boy Newton's got.
I got a bust of Isaac Newton
big
behind
Newton head.
behind the view of the camera right now.
Yes, you can't see it. There's a big creepy Newton head.
It's not creepy.
That is a creepy looking Newton
My boy's
head.
got his locks.
He's beautiful head of hair.
Yeah.
Okay, but why are his eyes closed? He's just like,
Oh, they look like death mask
yes,
eyes.
he's like, I hope they don't find out I'm gay.
No, stop. Realize he had no girlfriends his entire life. But he also had no boyfriends, as far as people could tell.
Okay.
He's claimed by the gay community in some books that I've read.
Right.
But he never procreated.
He never, you know.
It's easier to think. Today, we might just call him asexual.
Asexual.
I think
right.
that's just a simple.
And that's probably what he was.
Yeah. All right, go.
This is John A. He says, hello from Texas.
Texas.
I was wondering if particle fusion.
Why are you giving it? You don't know if he has an accent.
He said, hello from Texas.
Okay.
Particle fusion could be used as renewable energy source, as seen in Spider-Man 2. And if so, can it be done effectively? Love the show, you guys.
Oh, thank you. So let me say this two ways. So you can extract energy from the nucleus of an atom in two ways.
Right.
Take a big atom, split it, and the mass of the two products is less than what you started with. Where did the mass go? It became energy. E equals mc squared.
Nice.
The E and the M, they're on opposite sides of an equation.
Right.
If you get rid of the M, you get E on the other side. Okay.
And that is fission?
Fission.
That's fission.
Fission.
That's
big atom into little atom.
Little atom.
Now you come from the other side.
Okay.
You take little atoms and you bring them together, make bigger atoms.
Okay.
Okay. Then the atom you ended up with has less mass than the two atoms you started with.
Same in reverse.
Okay, so now we got some mass that becomes energy.
That's very cool.
That's fusion.
That's cool.
Fusion. Okay, so we know how to begin and sustain and contain fission.
Right.
Okay, a lot of research went into that to make the bomb.
Right.
Okay, that would be uncontrolled fission.
Uncontrolled
Okay,
fission.
if you're not controlling it, it explodes.
Right.
And that's where you get the bomb, the Oppenheimer and the A-bomb and all of this. And there are two kinds of A-bombs. One used plutonium, the other used uranium.
Wow.
Those are huge atoms. All right, you come from the other side, you start with hydrogen, the lightest atom. You fuse it, you make helium. That's what the sun is doing every moment of every second of every day, 24/7. Okay, so that takes very high temperatures And the temperatures are so high, like, what are you gonna put it in?
Right.
Okay.
I'm gonna go with
It's millions of
Pyrex.
It's millions of degrees.
Millions of degrees.
Everything you put it in will vaporize
before you even has a chance to do it.
This is one of the challenges of this exercise. And so maybe you can contain it in a magnetic bottle.
Ooh.
Yeah.
Yo, that's super cool
That's
because
dope.
now you're using a magnetic force
to contain it.
It's
brilliant.
brilliant.
It's brilliant.
I'm on board. Let's do this.
Why didn't we think of that before?
What are we waiting for? What are we waiting for?
So there are different styles of this exercise. The tokamak, it's a machine that creates a toroidal volume where you would then have your plasma, very high temperature gas, ionized gas, and in there you'd get the fusion. So the problem is...
Wow, that's so cool.
No. By the way, we've made fusion bombs.
Right.
So we have uncontrolled nuclear fusion.
Right.
They're called bombs.
Yes.
The sun is in full control of its nuclear fusion because at the center of the star, and the pressure surrounding it from all the rest of the star keeps it in check.
Right.
Okay? Otherwise, the whole star would go kablooey.
Right.
Official term.
Kablooey.
Kablooey.
I love it.
There's no uncertainty about the meaning of that word.
You can't mess that up. Kablooey.
So some of the challenges are, how do we control it once you get it started?
Okay.
And we've not been able to do that effectively, really. But recently, months ago, in the United States, and I think it was at Lawrence Livermore Labs, they managed to get more energy out
than they put in
to make this whole thing happen.
Well, that sounds to me like the nascent stages of fusion reactors.
Yes, it is. But they would... All the information about this wasn't fully reported on.
Uh-oh.
No. I mean, it's just the experiment, the energy that goes in the experiment versus came out, it was net positive.
Okay.
However, what it took to set up the experiment in the first place, the whole kit and the caboodle to get to that volume in which you had the fusion is itself a whole expenditure of energy and technology.
Exactly.
And so it's a first step to show you that it's possible. And what you have to do is make everything else efficient that's around it on the hope and expectation that one day this can run
like the electric car. Like the electric car, once you have it and you're driving it, it's doing great in terms of if you take renewable fuel and use that to put the electricity in the car, what you're doing is you're net zero.
Net zero.
But the fact is, if you made more pollution making the car
that makes no pollution.
Yes.
So it was an important test of concept. It made headlines, by the way.
Right.
And I was interviewed heavily about it, if I remember, on CNN and this sort of thing. So I was very happy about that because there's no shortage of hydrogen in the universe. It's the number one atom.
Yeah, right.
All right?
Yeah.
Did I tell you I was listening to a radio play one time? There were aliens that were coming to Earth to suck up our water supply.
Right.
Because they thrive on hydrogen.
Right.
And they knew that water is H2O.
Right.
H2O.
Right.
All right. And I'm listening to this. They came across the galaxy to consume our water supply.
Right.
To get
hydrogen.
When
only the most plentiful thing in the entire...
98% of all atoms in the universe are hydrogen. These are some stupid aliens.
Right.
And so I was very disappointed in that story.
Yeah, you get the good hydrogen on Earth. Come to Earth, the best hydrogen there is. Yeah, no.
So anyhow, there's no shortage of hydrogen.
Right.
And so if we could perfect this process, then it's unlimited energy for practically zero cost for the rest of the world and all of civilization.
Wow.
And it's not dependent on if the sun is shining or if the wind is blowing or if the tide is moving or what oil well you dug.
Right.
Or it's not dependent on any of that. Yeah.
Wow, it sounds like a wonderful dream. Well, listen, it sounds like we're on our way.
That's right, but people still have a spook factor about nuclear power.
Yeah. Well.
There's still, if you told them how many people died mining coal,
oh my God,
to supply their energy that we've been using for the past century and a half.
Right.
Yeah, it's hundreds of thousands of people.
Oh, without a doubt.
Right.
Not to mention how messed up their skin is just because of it. It's terrible.
Or their lungs.
Their lungs. God.
I had a geeky childhood. Right?
Okay.
So I always wanted to know what was the longest word in the biggest dictionary.
Okay.
And at the time, my access to dictionaries included the Random House unabridged dictionary.
It's the best.
Okay. I didn't know about the OED, but the Oxford English Dictionary, but the Random House was nice and big.
Yes.
Found the biggest word.
Yeah.
Okay. Mm-hmm. It's pneumono ultramicroscopic silicovolcanoconiosis.
God bless you.
Sorry.
So sorry. I'm so sorry that happened to
That
you.
is sensibly abbreviated to black lung.
Wow, is that what that is?
That's what that is.
Black lung.
So pneumono,
Right.
ultramicroscopic,
Okay.
silicover. So that's like the
Tiny
silicates.
little silicates
Right.
Inside the pneumono lungs.
Yeah, right. Canoconiosis. So it's, the medical folks staple together all the syllables. But
Right.
So that's coal, and it's coal dust, and people died from this.
Oh, yeah.
So I'm not here to say fewer will die with this. That's not the right way to approach this. No. Just demonstrate the safety of these nuclear plants, and maybe people will come around.
Pneumono stuff. Better known as...
Just cough it up. I don't know if it's still the biggest word in that dictionary. Plus, I don't know what the biggest word is in the Oxford English Dictionary. Okay. That's a whole other thing. A whole nother. But anyhow, why do we even go? Oh, because the safety factor is going to matter to people if they want to sort of vote this through. But we first have to make it efficient and scalable so that you can then have one in every city or wherever.
Yeah, so so John, it's not happening anytime soon, man.
And by the way, it has no byproducts such as what you get with fission. Fission has all these
that's called nuclear waste is what we call it.
Waste.
Nuclear waste. We got to put it someplace and it sticks around for 150, 200 years.
Or more.
Or more.
Right. Have you ever wanted one of your questions on the universe answered? We all have questions about the universe. From black holes to quasars, quantum entanglement, wormholes. There is no end to the depths of cosmic curiosity. Well, the entry level of Patreon membership with StarTalk gets you just that. I think it starts at $5 a month. You have access to the question line that reaches our Cosmic Query programming. And not only that, we produce a special Cosmic Queries installment just for Patreon members.
If you weren't the director of the Hayden Planetarium, what do you think you would be doing?
Okay, but this had to be another universe. It wouldn't happen in this universe.
Okay.
I'd be a songwriter for Broadway musicals.
Ooh!
So that's the entry level, and the perks ascend from there. There's a level, in fact, where we send you an autographed copy of one of my latest books. Right now, it's Starry Messenger, Cosmic Perspectives on Civilization. And it's signed with my fancy fountain pen with purple ink. So I invite you to just check the link below. And all of that money goes to our ability to experiment with new ways of bringing the universe down to Earth. So thank you for those who have already joined. And we welcome others to participate in this grand adventure of what it is to bring the universe down to Earth. As always, keep looking up.
All right, this is Charlie Cervone, who says, hello, Dr. Tyson, Lord Nice, Charlie from Hudson, Ohio here. This may be elementary, my dear doctor, but I've heard it said when discussing the accelerated expansion of the universe and the Hubble constant that the further away objects are in the universe, the more redshifted they are and therefore receding away from us faster. Wouldn't it stand to reason then that objects closer to us in time and space are receding more slowly and that the expansion is slowing over time? Can you please help me understand how this works? Thank you for expanding all of our horizons.
Oh, I see what he did there.
Yeah, did you see that?
Good.
Yeah, that was nice.
Very good.
Very good, Charlie. We're on to you, Charlie.
Very classy. So the first half was correct.
Right.
All right. As an object is farther away,
yes,
the way the expansion profile of the universe works is that those objects that are farther are receding faster from us. Okay. Those objects that are nearby are receding more slowly.
Mm-hmm.
Okay. As the universe expands, these things will all go faster. And so to think or suggest that it's nearby objects are receding more slowly, so therefore aren't what did he imply?
So what he's saying is that wouldn't it stand to reason that the objects closer to us in time and space are receding more slowly and that the expansion is slowing?
Oh, okay. So over time, because you got to throw a time factor in there. If you waited 1 billion years, those objects would be farther away from us and moving faster.
Exactly.
So no, nothing's slowing down.
Nothing. Right.
Yeah.
Right.
At all.
As a matter of fact, it's speeding up. Right.
Speeding up.
Speeding up that's the real problem.
That's the real problem.
That's the real problem.
Right.
It's actually.
I don't want to value judge nature. I'm not going to call it a problem.
Okay.
I'm just going to call it an observation.
All right.
Okay.
Okay.
The universe is expanding without limit, such that the universe will end not with a bang, but with a whimper.
Oh, that's terrible.
And not in fire, but in ice.
And you call that not a problem? What the heck is a problem then? That's not a problem.
Just right.
Okay, no. All right, so there you have it. I hope that satisfies you, Charlie. But thanks for the good question and the great little wordplay. So this is Danny K. He says, hello, Commander Tyson and Sergeant Nice. No, don't do that, Danny. It's Dr. Tyson and Lord Nice. Don't be giving us...
Maybe he doesn't know why they call you Lord.
Is that...
So he's just... He thinks people just giving you titles.
Just giving you titles.
Yeah.
Yeah.
Okay. All right.
Right. Yeah, no.
So maybe he's a new subscriber to the series.
All right.
He doesn't have the backstory.
He doesn't have the backstory of Lord Nice. All right, let me give it to you, Danny, real quick.
Okay.
Don't do that.
No, that's not
so here
the
we go.
backstory.
Is that not the backstory? No, I'm joking, Danny. I'm joking. What happened? Who was she? She was a 4-star general or 3-star
major
general.
So that's
She's a 3-star general.
We had a major general on interviewing her about, was it climate change or something?
Yeah, it was climate change.
Of something? All right. Yeah. And we had Charles Liu.
Charles Liu
was on. Charles did some wordplay with Gilbert and Sullivan.
Right.
Okay. And we said, you are the very model of a modern major general.
Because she's a major general.
We were doing Q&A, and people said Dr. Tyson and Chuck. Right? And you said, you got all pissy about it.
That's what happened.
And you said, why can't
I don't have a title.
How can I have a title?
Right, everybody got a title but me.
And the major general said, we will forevermore call you Lord Nice.
That's what it was.
And it's stuck ever since.
That's what it is, and it's stuck ever since. That's right. So the major general gave me that, Danny.
Yeah, and it's an earlier episode of StarTalk.
Well, here we go. I salute thee, he says, Danny Kringdongo, hailing from the flatlands of the Netherlands. A question I have, seeing as to so many sittings and other archaeological discoveries are being made underwater. Would this sudden rise in water volume be a result of those ice thingies melting due to global warming? Or could it be due to the Earth's position and distance from the sun and the moon? So, when we have underwater archaeological finds where there were civilizations and they're now covered in water, is that global warming, rising sea level, melted icebergs? What would cause that?
Yes.
Is what he's saying. And that's yes.
Yes.
Okay.
Next question.
All right, here we go.
So he's from the Netherlands.
Yes.
The Netherlands. And so they will be in very high demand as sea levels rise.
Yes.
See, it's a question suitable for someone.
Somebody from him,
The whole country is canals.
The whole country is canals and dams.
And dams and dikes.
And dikes.
Right, okay. They're going to be in high demand as sea levels rise, and we want to keep our land masses. Help us make these canals and dikes. And, we do it a little bit in New Orleans. There's whole sections that are below or at sea level that get flooded easily. So they have the levees, this sort of thing. Right. So the Dutch are experts at this. I mean, come on now.
Yeah, that's their whole world.
So I'm not surprised by this question. It's very much culturally informed and inspired. So as you go back in time to the last ice age, we know Earth was covered in ice and glaciers. Mm-hmm. Where did that water come from to become glaciers?
I'm going to say rain.
Rain? Where did the rain come from?
The sky.
Where'd the sky come from? No. Okay. How did the rain get in the sky?
Well, it evaporated from someplace else.
From where?
From the land. It was,
no, the land is frozen.
The oceans. It evaporates up, and then it becomes clouds, and then it goes someplace, and then it rains down, and then it freezes.
It snows down.
It snows down, not rains down. Snows down, freezes.
Does it return to the ocean?
Well, it can't because it's frozen.
Thank you. So then what systematically happens to the oceans?
Oh, they got to get shrink.
They systematically drain. And as they do that, more and more land masses manifest.
Is exposed.
That's correct. Coastlines grow.
People go, hey, this is a good place to build a city. Hey, guys. Hey, y'all want to build a
Before we had like advanced climate modeling. So no doubt there's no end of cities that just got flooded as we slowly came out of the Ice Age.
Gotcha.
And they had to move inland. All right. But that would have happened slowly as the water melted once again. Have you ever seen on a map? It might be true elsewhere, but I noticed, especially North America, off the East Coast, if they show the terrain of the bottom of the ocean, there's like what we call the continental shelf.
Right.
Which is the same coastline. It's just pushed out a little further. And then you have a big drop off.
Right.
Okay. When New York, when it used to dump its garbage in the ocean, it wouldn't do it on the shelf. It would take it to the deep part and then drop it out.
Right.
So it goes way down. Okay. So you say, where'd that shelf come from? That was the coastline when the oceans were less.
Gotcha.
Okay. So you can imagine New York City having been built way off on that edge. It'd be completely underwater now.
Right.
Okay. So the time scale of that is thousands of years. We're now going to have that happen in decades.
Yes. Yes, we are. So there you go. We'll be calling you, Danny, and all your friends in the Netherlands.
In 50,000 years, we're going to dig up, what's this city? They called it New York
New York?
City.
What the heck?
Yeah.
Right.
Oh, to him, it'd be New Amsterdam.
Oh, that's what it was.
Yeah, the Dutch had a little action here.
All of where you live in this city.
I live in Lower Manhattan.
Lower Manhattan.
New
That was New
Amsterdam.
Amsterdam.
Yeah.
Yeah, man. Wow. All right, Danny. There you have it. Well, please bring a bucket.
To bail.
We gonna need you. Bring a bucket, buddy, because we're in trouble. All right, this is Shane A. McDaniel. He says, hello, Neil. Hello, Chuck. Time dilation discussions usually involve one object moving faster than others to slow down its relative time. Alternatively, can an object somehow move slower than everything else to speed up its relative time? How might it slow down as such?
That implies that you can establish a speed absolutely measured, but all the speeds are relative to
one another.
So you can't say, hey, this one thing is not moving and everything else is. You're not making an absolute statement there.
Right.
You could say, I don't think I'm moving because I'm measuring everybody else to be moving. But what are they saying? They're saying you're moving by me.
Exactly.
Okay.
Which is the whole train thing.
That's the whole train.
That's the whole train.
When you're looking out the window.
When you're looking out the window.
Yeah, and you see
the train pulling off.
Yeah, it's are we moving backwards?
We're moving
No,
backwards. No, the other train.
Right.
It's
right.
relative to the other train.
Relative to the other train. So since all motion is relative, hence the name of the theories of relativity.
Okay.
Since all motion is relative, you cannot declare that you are not in motion and everybody else is.
Gotcha.
Everybody can declare they're not in motion.
Right.
And everybody else is.
So you can declare you're not in motion, but then as soon as you go on the other side, you're like, oh, no, I'm in motion.
Exactly.
Right.
You know how this came up? It came up in a football game.
Get out.
I got a text from, who's the coach of the Seattle Seahawks?
Pete Carroll.
Pete Carroll texted me. He said, Neil, we just had a play where they want to call it against us, where they had what happens if you lateral backward, forward lateral?
That's an illegal forward lateral.
Illegal forward pass.
Illegal forward pass.
Because the quarterback.
The receiver has to be behind the quarterback. You can only go backwards.
Provided the quarterback has crossed the line of
scrimmage. If you're past the line of scrimmage.
Right, but otherwise it's a forward pass.
Yeah, you can forward pass, right.
So they were in a play where the quarterback, Russell Wilson, he doesn't see an open receiver, so he scrambles.
Right.
He crosses the line of scrimmage. He sees one of his running backs, and he pitches to his running back. Okay. No, sorry. He pitches backwards to his running back. And then he goes down, and the running back gets a first down, and I think they scored on this play. Okay. And the other team said, no, that was a forward lateral and illegal. If you go to the videotape, the point on the field where Russell Wilson releases the ball is behind the point on the field where the running back catches the ball.
Oh, yeah.
From the point of view of the field,
right,
it is a forward pass.
Right.
But they were running
running together. So relative to one another, they still remained a backwards lateral.
Correct.
Wow.
Correct.
Wow.
Correct.
Wow.
And it's not their fault they were running faster than the ball sideways motion.
Right.
Okay? So in other words, he was running so fast
That's
forward.
what happens with them black players. You can't even tell. You can't tell where the ball is. This Negro is running fast.
So he's running so fast that when he throws the ball backwards,
right,
the ball actually ends up
going forward.
Okay.
Right. Okay. He throws the ball backwards, but he's running so fast that when the guy catches the ball, he's past the point
where he let go. Okay. Even though he was behind him the whole time. Okay. So I analyzed it and I tweeted back and I said, according to the field, it's a forward pass, but according to the moving reference frame of the players,
right,
it was a legit
lateral.
And that's, you know what that's called? A Galilean transformation.
Ooh, what's even got a name?
That's got a name.
Dog.
A Galilean transformation. You take one coordinate system and transfer it into another.
Nice.
And it's a completely legitimate, it's just a different coordinate system.
Right.
And from the coordinate system of the running players, everything was legit. And you should not penalize them just because they can run so fast. And so the play stayed. I gave Pete Carroll some extra ammo to make sure it wouldn't get overturned.
That's cool, man.
Yes, that's still online. I mean, still.
That's great.
So anyway, so that's this.
So that's relativity in a nutshell, right there.
Look them up. Galilean transformation. And we talked about this a little in some other where, you know, you've been on the freeway and there's always somebody who's racing somebody else.
Always.
And they're darting in and out among the cars.
Right. And I was in a hurry.
Okay, you're going 60 miles an hour, they're going 90 miles an hour. Mm-hmm. Okay? In and out among the cars. However, they're not really going 90 miles an hour relative to you.
Right.
They're going 30 miles
an hour.
Because it's 90 minus 60.
Right.
So it feels dangerous when you see this, but as long as everybody is just moving at 60 miles an hour, as far as they're concerned, you're standing still and they're driving 30 miles an hour among you.
Right.
So it gets dangerous if you decide to not do 60 miles an hour and just turn the car while it's coming by. Then definite accident. And the accident will feel the 90 miles an hour because his body is moving now 90 miles an hour and then it moves 0. And then basically you don't survive that. So it's lethally playing with the laws of physics.
Jake from State Farm, I hope you listen.
Jake from State Farm. No, this would be a job for Jake and Flo. Right. You need Flo from Progressive.
Yeah, exactly.
Double that up.
Jake and Flo. All right, here we go. This is Karthik. Karthik says, hello, Dr. Tyson, Lord Nice. This is Karthik from Berlin, Germany.
Ooh.
If the earliest light from the universe to reach us is represented by the cosmic microwave background radiation, which is from 380,000 years after the Big Bang.
Yep.
How did we determine how far back from that point the Big Bang took place? So he's saying, how do you know 380,000 years gave you first light from the source of the light, which would have been the Big Bang itself?
So where do we get 380,000 years?
And that's basically
what he's asking. Okay, so a lot of the action took place in the first fractions of a second. There's an excellent book written by Steve Weinberg, a brilliant physicist, won the Nobel Prize. He wrote a very successful physics book, small, called The First 3 Minutes.
That's amazing.
And in there, it takes you from the moment of the explosion of the Big Bang to what went on in the universe after 3 minutes. And I turned those first 3 minutes into most of the first chapter of my book, Astrophysics for People in a Hurry. Because the first chapter is called In the Beginning.
Ooh.
That's the name of the first chapter. So I detail it. So
there's another book, I believe, that starts.
that has a chapter.
I think there's another book with a chapter that starts in the beginning. I'm trying to think.
Stop.
I'm pretty sure.
Okay, you keep thinking about that.
Yeah.
You call me when you know.
Yeah. It'll come to me.
That was the old joke when you were a kid. How do you know God was a baseball player?
I don't know how.
He started in the big inning.
Oh. Wow.
Yeah,
how do you know God wasn't a comedian? That joke.
That was like safe for elementary school joke.
Yeah, that's cool.
So what you do is you create all the physics necessary to give you that cosmic microwave background.
Gotcha.
And once you know how much mass is in the universe, and you ask yourself, what must have been going on in the universe to give us that state where the photons run free and you get the cosmic microwave background?
Right.
Once you do all of this, the time it takes to get to that point turns out to be 380,000 years.
That's amazing.
Right. It's all very well-established physics.
And you know what's funny? Right now, there are people hearing this, and they're like, no. It is so counterintuitive. But it's like, oh, no, that's what you believe. And what they don't understand is that we can see the cosmic microwave background.
Yeah.
It's not a belief.
Right.
We can see it.
We measure it.
We measure it.
Yeah. And so do we know what matter must be doing in order to create that environment?
Exactly.
And we're expanding now. So here's what would have to happen if we were wrong. Somehow the universe was birthed into that state, but with nothing before it. But we can account for that provided there was a universe before it, using known laws of physics as detailed by Steven Weinberg in his book from 1970s. That book came out.
Wow.
And in my book, I give a full exposition of the first moments of the universe. In fact, one of these chairs,
right, the ones that
one
were
of these
sitting
chairs
that were awards to him for writing.
I won for an essay called In the Beginning.
In the Beginning.
Which basically birthed that whole first chapter of my book.
Look at that, the universe is crowning. Oh, Lord, I don't know nothing about birthing no universes. Oh.
I wonder how obscure that reference is to.
I'm sure. So most people have no idea what I'm talking about right now.
You're talking about...
they have no idea.
Gone with the Wind.
Yeah, exactly.
You know.
And most people have no idea.
Yeah, okay.
Yeah. Maybe they'll look it up. It'll be a meme somewhere after somebody will put it out as a meme so that the kids can know the joke that I made.
I don't know nothing about birth and universes. So it's known laws of physics that get us to that point.
Right.
That allow us to conclude how much time before
How to go back.
How to go back.
Because you get to that place and now you can go back
Now you
from
go back.
everything that you know at that place.
Correct.
That's really, God, I love science.
Oh, well, you know what else? As you go back, matter is behaving in all these ways under the temperature, pressure, energy, and all of this. You can make predictions in that time that says, 98 out of 100 atoms in the universe should be hydrogen. And that's what we see on the other side of that fence.
Fantastic, man.
Right.
That's
right. No, it's extraordinary.
Brilliant.
Yes.
It's brilliant.
Yes.
I love it.
Yes.
All right.
Well, by the way, that cosmic microwave was predicted. It was predicted by a guy named George Gamow.
George Gamow?
Gamov.
Oh, Gamov.
It ends in a W, but it's Russian, so it's a V sound.
Gotcha.
Gamov. He was on a paper with two or three other authors.
Right.
Where they said, if the universe began with an explosion, knowing what we know about quantum physics and matter and energy and temperature and time, what should have happened? It would expand, it would begin to cool, the energy would become matter, the matter would coalesce, and at this point, light should escape. We should look out in the universe for a universe that has a temperature of about 5 degrees. And so we looked.
Yes.
And we found a universe that was 3 degrees.
Yes.
They were so off.
Idiots.
So Rich God, a friend of our show, he characterized this prediction. He said, it's like saying that a 50-foot flying saucer, predicting a 50-foot flying saucer was going to land on the lawn of the White House, but it was a 30-foot flying saucer.
That's good.
Right? So the fundamentals of the prediction are really right, and the details are something that would come out later.
Wow.
Yeah. So we're good back there. That's all. By the way, if one day we need to sort of rethink the Big Bang, it would not be to discard what works. It would be to see that the Big Bang fits into an even larger
picture of
the universe.
Right.
And the press is always trying to ditch the Big Bang.
Right.
They're always pooping on the Big Bang.
Yeah.
Because they think we're just making stuff up.
Yeah, because it's not going to be one of these things where it's just like, oh, we were just completely wrong and now that's not a thing at all. No.
That doesn't happen anymore.
Right. No. It's like
it happened before the year 1600.
Right.
But
it
after
can't
then,
when
we test everything and it doesn't happen that way.
It'll be a further explanation of what we already know.
It'll be a deeper understanding of what we already know. Correct.
Right. I love it.
Hey, StarTalk fans. I don't know if you know this, but The audio version of the podcast actually posts a week in advance of the video version. And you can get that in Spotify and Apple Podcast and most other podcast outlets that are out there. Multiple ways to ingest all that is cosmic on StarTalk. Okay, let's do a quick lightning round because we're running out of time.
All right, this is Mo Fury. He says, hi, Dr. Tyson.
Somebody named Mo?
Mo.
Cool.
Love that.
His last name is Fury?
Mo Fury. He's
That can't be real.
He's a Marvel character.
I know.
He's the less menacing brother of Nick Fury. I'm Mo Fury. Hey, Thor, what's your problem? It's me, Mo Fury. Captain America. Hey, you got an attitude or something? I don't know what your problem is. It's me, Mo. Okay, I don't have an eye patch. I wear glasses. All right. He says, hey, Dr. Tyson, Baron Nice. Okay. I live on a pale blue dot in Tennessee called Nashville. I don't know what that means. As such as I dream about exploring the cosmos, let's say we have one world war in the next century or two. Well, this is off to a positive start.
I know, right? Right.
Given that, do you believe humanity will be gallivanting around the solar system by then? I don't mean governments. I'm talking about normal working class people who live and work all over the system like the stories in The Expanse. Great show. Thank you, Mo. Sans the spherical wormholes, of course.
Why does this have to do with another world war?
Would we be able to escape because regular people have the capability of exiting this planet for another destination?
If regular people have that capacity, so does the military, who might be chasing your ass if you're the enemy. Okay? I will answer this with a quote from Albert Einstein.
Okay.
If I may.
Please do.
I do not know how World War III will be fought, but I know that World War IV will be fought with sticks and stones.
Ooh. Oh, that is so disturbing. Oh, my God, that sent chills down my spine because that just says everything.
It says everything about everything.
It says everything about everything.
Yes.
Like,
we're done there.
That's it.
That's it.
That's a mic drop and a half.
Yes.
Yeah.
If they had mics back then.
If they had mics, which were made out of sticks. Took a stick and put a bunch of dead leaves on top. Is this thing on?
You're tapping it.
You tap the dead leaves.
Okay. Slip in another. What do you got?
All right, here we go. Stephen Banker says, hi, guys. Question about time. Is it possible to measure a length of time shorter than the steposecond or zeptosecond? Zeptosecond. I can't say it. Zeptosecond. Okay. If so, can we measure infinitely small spans of time? How would we have ever gotten to the point in time if there were possibly an infinite number of moments between the Big Bang and now? Wow, this guy, I love you, man, because you...
Okay, there's a little bit of Zeno's paradox in there, which is not a thing.
And this dude smokes weed, okay? I'm telling you, Stephen Banker, that's a weed question right there. That's a weed question.
Okay, all right. I didn't know that's a category of question. So...
I love it.
Couple of points there.
Right.
There's something called the Planck length.
Okay.
The Planck length is the smallest unit of space within which no laws of physics have any meaning. Okay? So in quantum physics, space is quantized by these little units of space.
Okay.
Okay? So the time it takes light to cross a Planck length, it seems to me would be the shortest unit of time because there's nothing that can take place inside of a Planck length.
Ooh, lovely.
Because that is the pixels of life.
So it's like you're traveling in between the actual pixels that make up the picture itself.
Yes, yes. So you go pixel to pixel,
right,
but there's nothing in the pixel for you.
Right?
Because a pixel is just, there's no more detail there for you.
Got it.
So that would be the shortest unit of time possible. Anything shorter than that, I don't know that you could measure it, nor would there be anything there to measure.
Right. So there's no medium there.
No, nothing.
There's nothing there to for you to put any kind of ruler up to and say, this is where we are, this is where we're going.
Correct.
Anything.
Because units smaller than that have no meaning.
Right. Doesn't make a difference.
In the quantum universe.
In the quantum universe, it has no...
By the way, general relativity requires space be continuous and not quantized. if you want to marry general relativity and quantum physics, you need somebody's got to be there for the ceremony, for the shotgun marriage. Because the shotgun marriage was taking place in the early universe, because quantum physics is the physics of the small, general relativity is the large-scale universe. When the universe was small, there's quantum phenomenon influencing the entire universe. Because the universe at one time was small. Okay, so let's say you could divide time infinitely small. Zeno's paradox is, you know Zeno's paradox?
I don't.
You don't know Zeno's paradox? Okay, you have a destination. Well, you got to travel half that far. Now, with what's left over, you got to travel half that far. What's that? You got to travel half that far.
Are we there yet?
You got to travel half that far. Okay,
right.
You keep doing this.
You're never getting there.
Never getting there.
You're never ever going to get there.
But you end up getting there.
Right.
So that's Zeno's paradox.
Exactly.
Okay, so we would learn how to solve this mathematically. It's because the sum of those halves, even though there's an infinite number of them, they sum to a finite answer in a finite amount of time.
That is dope as hell.
Okay.
That's amazing.
Yeah, so this...
It's the finite containing the infinite.
Yes. Brilliantly worded.
That's amazing.
Lord nice. Yes, the finite can contain the infinite, and indeed it does.
And it does. That's great.
Yeah. Yeah, so he shouldn't worry about that part of the question.
That part of the question, yeah.
Okay, fast one, last one.
All right, here's the last one.
Promise,
Here we go.
last one.
Ali Khan Hemraj. Ali Khan Hemraj. Okay? Your new name is Al. Okay? This is from Al. Al says...
You renaming people just for your own convenience?
What can I say, man? I hope I got your name right, buddy, or person. Hello, Dr. Tyson, Lord Nice. I was wanting your thoughts on if transporter, like in Star Trek, could one day just be possible. And P.S., Dr. Tyson, I saw you in an episode of Velma. It was awesome. What's Velma?
You know what Velma is?
No, what's Velma?
Velma is from Scooby-Doo.
I know. Oh, Velma.
The woman in Scooby-Doo named Velma had her own show on HBO.
Get out.
And she's in high school. The dog doesn't exist yet. And it's really sort of the birth of the
Mystery Machine.
It's the roots of their origins.
Oh, wow.
Velma. Yes, I had a brief cameo in it.
Okay.
Yeah.
Good for you.
I think I was a teacher. I forgot exactly what. It has to make, if I'm going to be a cameo, it's got to make some sense, right? I'm not going to be like...
You're not going to be a drug dealer. What's up, Velma? What you need today, girl?
It's got to make some philosophical sense that I am in the program.
Yeah, okay. All right. So anyway, here's the deal. Transporters, which break down your molecules inside of a machine that remembers the imprint of your molecular structure in every single detail, then turns that into a beam of energy, transports it someplace else, shines that beam of energy to another place where it then reconfigures all of those molecules in the same configuration so that, bang, now you have been reassembled molecule by molecule. Could that one day be possible?
Okay, I said I'd give a soundbite answer. This is going to be hard.
Okay.
Okay, are you ready?
Yep.
All right. In 1900, New York City, there were horses everywhere.
Yes, there were.
And where you have horses, you have manure.
No, that's for sure.
I read, I have found this hard to believe, but maybe it's right. I read, on average, a horse poops 30 pounds of manure a day.
Woo.
It's in the streets. Flies are attracted to it.
Oh, God.
Back then, there were no supermarkets. People sold their goods on the street, on street carts, including fish. And so it was nasty.
That's nasty.
Unsanitary.
Terrible.
And people trying to find solutions to this. Do you give horses some different kind of feed so there's less poop? Do you put something in the feed so the flies don't want to reproduce in it? Do you, what do you do?
Right.
And how do you cart away the poop? Well, you got to bring in other horses and put it in a wagon that they drag out, but then they're pooping while they're dragging out the poop that they're taking out of the thing. Okay?
This is poopalicious.
So how do you solve this problem? You invent the car.
There you go.
Okay?
Right.
The car solved that problem.
Right.
I assert that the transporter, as brilliant an idea as that was, which allowed the original series to not have to land rockets on surfaces, which would have been a whole overhead of special effects.
Right.
So they said, we need another way to do this.
It also ruins most of the storylines.
No, you need a place to put your rocket. You know,
right.
And you can't beam into a place to get the job done.
Yeah, you can't get the job. Yeah, you got to land.
You got to land and get out of the rocket.
Right,
Okay.
that sucks.
So it was a brilliant visual mechanism vocabulary for this storytelling. Okay. I'm thinking by then, no, you won't get transported. We just open a wormhole.
Oh, there you go.
You step through, now you're on the planet.
Boom.
You're not disassembled and reassembled
Right.
with the risk that maybe something goes wrong.
Using the structure of quantized space.
Thank you. There it is. And so any place you would otherwise beam, you just simply open the wormhole and step through. So I think that, like the car solved the poop problem, wormholes will solve the transporter problem.
Let me tell you something. That is a much better answer than I ever thought you would give. I mean, that's a really good answer.
And so ends the next episode of StarTalk Cosmic Queries, Grab Bag Edition, which Chuck still keeps calling
Galactic Gumbo.
All right. Always good to have you, Chuck.
Always a pleasure.
All right. Neil deGrasse Tyson here. We're out of time. As always, keep looking up.